and welcome to Math World. Today we're going to talk about the Pythagorean Theorem. Now, while this theorem does relate to triangles, we do first have to understand how squares and square roots work. So let's do a quick review. So for example, if I take the number 7 and I square it, you put a little 2 over it, remember that means 7 times 7, which is 49. So that's how you square a number. Another example would be 8 squared. What's 8 times 8? 8 times 8 would be 64. All right, now that's a square. Now square rooting is working backwards. So for example, if I take the number 49 and I square root it, the square root symbol looks like this. Well, that's saying, okay, take 49 and figure out what number times itself makes 49. And that answer, of course, would be 7. We know that. And the square root of 64, well, that would be 8. All right, now keeping that in mind, we can use that to use inverse operation to solve the Pythagorean theorem. All right, so let's go ahead and begin. I'll kind of move that off to the side for now. All right, so the Pythagorean theorem tells us that any triangle, any right triangle, now this only works for triangles that have a 90-degree angle. Usually they put this little square here that means 90 degrees. For any 90-degree right triangle, if I have 3 sides, maybe side A, side B, and side C, this theorem tells me that the length of side A squared plus the length of side B squared will always equal the length of side C squared. That's the theorem. And Pythagorean was a real person who kind of discovered this. All right, so for example, if I said this side length over here was 3, and it doesn't really matter which side I call A and B, but it does have to be the 2 shorter sides. So maybe side length A is 3, side length B is 4, and let's make side length C the longer side. You can see this is the long diagonal that is across from the 90-degree angle. That's always the longest side. It's called the hypotenuse. Let's make that 5. All right, so if A is 3, B is 4, and C is 5, let's see if this works. Well, 3 squared plus 4 squared should equal 5 squared. All right, well, 3 squared means 3 times 3, that is 9. 4 squared, 4 times 4, that will be 16. And 5 squared, or 5 times 5, is 25. And indeed, 9 plus 16 is 45. And so Pythagoras, who discovered this, realized that it worked for every single combination of 3 sides of right triangles. All right, so now that we know that this is a fact of math, that it will always work, we can really use this to figure out some missing sides of other triangles. So that's what we're going to be doing now. All right, don't forget about the square. We are going to use that soon. All right. So here's another triangle. And, you know, it's not perfect, but it's good enough. And we'll say that this is a right triangle. It's going to get the little right triangle symbol. Okay. So now let's give ourselves some side lengths. Maybe I say that this side here is 6 and this other leg is 8. But I'm not going to tell you what the longer hypotenuse is. Can we figure it out? Well, this is where we're going to use our a squared plus b squared equals c squared theorem. A squared plus b squared equals c squared. And the more you write out, the easier it is and the less confusing it gets. Because remember, we said that a and b are the 2 legs. They're the 2 sides that are closest to this right angle, the 2 smaller sides. It doesn't matter which one I make A or B, as long as I include them both. I'll even do it in an opposite order that I did last time. It doesn't matter. Maybe I'll say this is side B and this is side A. It does not matter. All right, what does matter is that C is the hypotenuse, this long edge furthest away from the right triangle, from the right angle. That does have to be C. And we don't know what it is yet, so I'm just going to put C. Now I'm going to go ahead and put a square over everything because that's what our theorem says to do. So 8 squared plus 6 squared should equal mystery amount squared. All right, well, let's go ahead and complete this math to try to figure it out. So we know about 8 squares. We actually saw that in our example. We know 8 squared is 64. 6 squared, hopefully know is 6 times 6 or 36. And then, again, lastly, we have C squared. We do not know that yet. We can go ahead and combine 64 and 36, though. Those add to make 100. And now we're left with something that says 100 equals C squared. This is where we get to use our inverse operation and our square root knowledge. All right, so what I'm going to do here is actually do the inverse operation of this little square symbol. The opposite of squaring we said was square rooting. So I'm going to draw a square root symbol over the C square. But remember, if you do something to one side of an equation, you have to do it to the other side. So I'm going to have to square root the left side of the equation as well. What that leaves me with is, it leaves me with a little cancellation on the right side. The C squared and the square root symbol, these are going to kind of cross out. You see, they're going to cancel each other out, leaving only a C. And on the left side, well, I get the square root of 100. What number times itself makes 100? That would be 10 times 10. If you're not great at knowing your square roots, you can use a calculator and actually type in 100 and then hit the little square root button. In my calculator, it's right here. So I'll hit square root and it tells me that yes, the answer is 10. 10 is a number that multiplies by itself to make 100. All right, so square root of 100 is 10. That means that C must be 10. That is my missing hypotenuse length, 10. All right, so that's how we use the Pythagorean theorem to figure out the hypotenuse. If you have any questions about this, please put them in the comments or reach out to me. Now, where this gets a little more interesting is we can also use this theorem, the Pythagorean theorem, to find any of the missing sides, not just the C value, not just that hypotenuse. So let's take a look at another example. So let's draw another triangle here. I'll try to make it a good looking right triangle where we have a right angle. Okay, now in this example, I'm going to give two amounts. I'm going to give an amount here of 12. I'm going to give the hypotenuse amount of 13. Again, I know this is the hypotenuse or the longest edge because it's farthest away from the right angle. Now what I don't have is this lower leg. Okay? So let's go ahead and fill in our Pythagorean theorem. We'll start again with writing it out so we can not get confused. A squared plus B squared equals C squared. Alright, now in this example, unlike before where I knew A and B, this time I do not know both A and B. I only know one of the smaller sides. I do not know the other one. So I need to make A or B 12. And again, it does not matter which one you make 12 between the A and the B, so I'll just say A can be 12. I'll put a little square over it. And now when I get to go write B, I don't know B, so that's the variable I'll leave as B. I will still include the square symbol, because that's in my formula. And then I'll say equals, now instead of C squared, I do know C. I know C is 13. I know my hypotenuse is 13, so this time I get to fill in the C value. And again, include the square. So you can see the slight difference in this, this method when we're trying to figure out a leg. Alright, well, let's go ahead and start to do the math to see if we can use our inverse operation again. 12 squared, that is 144. I don't know B squared, so I'll just leave that as B squared. And 13 squared, that is 169. Of course, using a calculator if needed, to figure out these amounts. All right, now at this point, I'm not ready to go jumping into square rooting yet because, I have this 144 still here. So I'm going to get rid of that 144. I'm going to move it away from my variable b by subtracting it from both sides. I can use inverse operation doing the opposite of adding 144. I can subtract 144 from both sides. Now that's great because that will eliminate the 144 on this left side, and it will leave only the b squared on the left side, which is great. I'm starting to get things away from my variable. Now 169 minus 144 will leave us with 25. All right, now that I have a variable all by itself, except the little square above it, we can get rid of that square by square rooting. The inverse operation of squaring is square rooting. Let's square root that little 2 away, say bye-bye square, and we are left with only a b on the left side of the equation. On the right side of the equation, we have the square root of 25. Well, that's something you should know. What number times itself makes 25? 5, because 5 times 5 is 25. So we now figured out that b is 25. Great job. Now we did not figure out the hypotenuse. We figured out that lower leg. It's 5. So we can use the Pythagorean theorem to figure out both the hypotenuse and either the legs. This will work with no matter which leg I gave you, you can figure out the other one. All right, so Pythagorean theorem. The last thing we can do, which is kind of neat, is you can actually use the Pythagorean theorem to figure out if a triangle is a 90-degree triangle at all. So let's say I drew a triangle. Here we go. And we're not really sure whether or not this is a 90 degree. I'm not going to put the little 90 degree symbol on it this time. We don't know whether it's 90 degrees or not. All right, well, what if I gave you all 3 sides? Then could you tell me whether it was 90 degrees or not? Let's try. So what if I said this is 4, this is 5, and the hypotenuse is 6, the farthest away from where the maybe right angle is. All right, so, well, let's use our formula. We know it's supposed to be a squared plus b squared equals c squared. This should work for all right triangles. It doesn't matter which one we choose for a and b. I'm just going to choose 4. So 4 squared plus b will make that the other lower leg, 5 squared, equals the hypotenuse of 6 squared. All right, let's check it. Well, 4 squared, that makes 16. 5 squared, we know is 25. And 6 squared is 36. All right, let's keep going. 16 plus 25, that's going to make 41. Wait a second, 41. 41 is not equal to 36. That's bad, which means this, since it did not work, Pythagorean theorem didn't work for this triangle. This is not a right triangle, not a right triangle, meaning that degree down here, it's going to be something other than 90 degrees. I don't know. This only works for 90-degree triangles. Okay, and if they don't give you the triangle like I just did here, if they only give you 3 numbers and ask you the same question, draw yourself a triangle, or you don't even need to, just do the math and see if it works. Okay, well, that's pretty much it for Pythagorean theorem. Of course, you can use this in a number of variety of ways with word problems, putting a ladder up against a wall and seeing, how tall the ladder has to be, and that's it. I'll see you in class. Hey class, it's Mr. Bigsby with a hat, and I've got a challenge problem for you. Alright, so this is my house. My house is about 12 feet tall, and I want to get to the top using a ladder. Alright, so if I put a ladder at the very top and I put it to the ground, I know my ladder is 15 feet long. The question is, how far away from the ground do I need to put the ladder? Where should I stand so that it can reach the top. All right? Leave your answer in the comments. Later. Now for a word from our sponsor, Paper Cut Games. Today we're going to review a game called Brave Rats. This is one of my favorite games because it's an easy to carry around two-player game that is easy to learn. Basically, each person's going to get the same exact hand of 7 cards, and they're these little rats. And now the goal of the game is each person's going to secretly choose one of their rats to play down, and then once they're both face down, you flip them over and see who wins. And in most cases, the higher number will beat the lower number. But there are some special rules, such as the 3, the assassin, actually wins if it's the lower card. Or the general will give your next card a +2. So each card kind of has like a little bit of a flavor to it. And of course, the best flavor of the game is the prince versus the princess. The prince is a 7, which is the best card, and the princess is a 1. However, the prince is in love with the princess, so if the princess gets played, the princess automatically beats the prince and wins the entire round. Otherwise, you play until usually people get 4 victories, and that's the game. And then play again. It takes about 2 minutes to play, so that's why it's really fun and quick. Go ahead and check out Brave Rats. I'm Mr. Bigsby, and I approve this message.